Okay, hello everybody. Let's continue. So we have just mentioned about the procedure of the test. And here, let's look at here. How to get the standard way of the statement of the decision in medical statistics. So here, if H0 is rejected, that means in one sample z-test, the population mean is significantly different from the hypothesized value at the alpha level of significance. And if H0 is not rejected, that means the population mean is not significantly different from the hypothesis value at the alpha level of significance. So here we have only two kinds of decisions or only two kinds of statement in hypothesis testing. The first one is H0 is rejected. And the second one is H0 is not rejected. So we have mentioned that when can we reject H0? Do you remember that? When can we reject H0? Yes, when P is less than or equal to alpha. At this time, we reject H0. So we can just copy the statement here or the words here. So that is the conclusion for the hypothesis when P is less than or equal to alpha. So when we cannot reject H0, that is P is bigger than alpha. When P is bigger than alpha, we cannot reject H0. So both of these two conclusions are the standard way statement in medical statistics. Okay, now let's take an example. Suppose we want to compare fasting serum cholesterol level among recent Asian immigrants to the United States with the typical levels found in the general population. Suppose we assume cholesterol levels in women in the United States are approximately normally distributed with mu equals to 190 and sigma equals to 40. Blood tests are performed on 100 female Asian immigrants, and the mean level X bar is 181.52. What can we conclude on the basis of this evidence? So here, let's think about the question at first. What can we conclude on the basis of evidence? So that means the question is to identify if there is any difference between the two populations or not. So please remember that estimation is used for estimating population parameter with the sample statistic, but the hypothesis testing is used for identify the difference between populations. So if the question is about difference, that means we can use the method of hypothesis testing, not estimation. So here, this is a question about hypothesis testing. And now let's think about the information which is given in the question. And here we can find so many numbers in the question. The first one is this one, 190. That is mu. So that means it's the population mean. It's some informations from the population, the given population. And we can also find sigma. It's also another information from the given population. So what is the population here? We can find that. Suppose we assume cluster levels in the United States, and we can know that the population is the cluster level in women in the United States. So this is the given population, that is United States women. And we know that the mu of the population is 190 and its sigma is 40. So this is the given population in the question. And next one, let's find another number. Blood tests are performed on 100 female Asian immigrants. Here, there is another number, 100. So what's the meaning of 100? It's the number of persons, right? We find that in the population of United States, there is no any number of persons, right? So we can consider that is a population. But this group of persons has the number of persons. So that means this must be a sample, not a population, right? Yes, so what is the sample here? Is that the sample of United States? Of course not, right? We find that the sample is from the Asian immigrants, the female Asian immigrants, right? And the number of persons in that sample is equal to 100. So this number 100 is actually sample size, right? The little n equals to 100. And this is the given sample, that is female Asian immigrants consisted with 100 persons. So this is the given sample. And we can find that in this question, we have two informations. The first one is a given population, which represents the United States women. And we can get another information that is a sample, a given sample with 100 female Asian immigrants. So we can find only one sample, right? There is only one sample in this question. And we know that the X bar, that is the sample mean of the sample, is 181.52. So there is a single sample and a given population in the question. So that must be one sample test. One sample test. And let's think about the precondition for z-test. Z-test is used for one sample test, right? And there is another precondition. That is, the mean must follow a normal distribution, right? Okay, so we can find that this is normally distributed, right? And the third precondition for the test is sigma is given, or the variance is given, right? Sigma is actually standard deviation. So that means the standard deviation is given, or the variance is given, we can use the test. So here, let's think about it. So what is the sigma? We can find it here, right? Sigma is given. So here we can use the test to solve the question. Okay, so here, let's think about the procedure for the question. That is step 1, step 2, and step 3. So here, step 1. We establish two statements of hypothesis. The first one is H0, and we have mentioned that H0 means there is no difference between the two populations, right? And here we use mu to represent the population mean of Asian immigrants. But we know that in this question, what we can only know is the sample from the population. So this population is not given in the question. So we use mu to represent the population mean of Asian immigrants. And the given population, the US, the female in United States, that is given, right? And we have already know the population mean of the given population. So here we use mu0 to represent the number of the given population. That is 190, right? So H0 is the population mean which is not given, equals to the one which is given in the question. So we use mu equals to mu0, namely 190, as the null hypothesis. And HA should be not equal, right? So that means mu is not equal to mu0. And don't forget the very important number, alpha, the significance level alpha. Alpha is 0.05. That is the most commonly used number in statistical inference. So this is step 1. And step 2, we need to calculate the test statistic, because we use the method of z-test, and here the test statistic should be z-value. And we have mentioned the formula for z-value. We need to use x bar, the given mu0, sigma, and the sample size. And we find that all the numbers is given in the question. So we just put all the numbers into the formula. So x bar equals to 181.52 minus 190 over 40 over square root 100. And we can get the result. The result is negative 2.12. And the step 3 is to make the decision of rejecting or not rejecting. How can we do that? We need to use table A1, right? We need to use table A1. So let's check it. Let's check this number in table A1. Okay, this is the appendix table A1. That is the cumulative distribution function for standard normal distribution. Actually, this is the table of z-value and its corresponding probability. So here, we get a number of z as negative 2.12. So let's find it. 2.12. And I think you can use, and you know how to use table A1. So the first one, let's find the minus 2.1 here, and 0.02 here. it's here, right? And in the cross position, this number 0.0170, this number is the corresponding probability with the z value of negative 2.12. So we find that the probability is 0.017. This number is less than 0.05, right? So that means here the p value is less than alpha. So we know that when p is less than alpha, that means the probability is too small and we can reject H0. Because if we suppose H0 is true, we get something with a very, very small probability. So that means what we suppose to be true is not really true. So we reject H0. Here we reject H0. So the conclusion here is the cholesterol levels among recent Asian immigrants are significantly different from those in the general US population. Average value of mean cholesterol levels 190 at the 0.05 level of confidence of significance level. So actually that means there are differences between the two populations, between the population of Asian immigrants and United States. So that is the result to the question. So this is the method of z-test. Okay, next one. Z-test is a method of hypothesis testing. And now, how can we solve the question in one sample of the estimation? So next one, let's learn the confidence interval with z distribution. So that means we also use z value for the estimation of parameters. And here we use the method of confidence interval, not point estimation, because point estimation is not very correctly. So here we use confidence interval. But please notice that this method for confidence interval is still based on z value. So we need to use z value and the table A1. Okay, so here, the first one, let's look at the precondition for confidence interval with z distribution. Determination of a 1 minus alpha confidence interval for the mean of a normal distribution with known variance. So we notice that the precondition for the confidence interval are almost the same with the one sample test, right? It's also based on the normal distribution and the given variance. So that means when sigma or sigma square is given, we can use this kind of method, which is based on z value. So this is the formula for the population mean for the confidence interval. And how can we get this confidence interval? I think we have learned that in chapter 2 in the normal distribution. But I will still explain that in this class. This is the formula for z, what we have mentioned just now. And here we find that z value is a special number what we can get from the table A1. X bar is the mean of the sample, and we can get that number with the data of the sample. Sigma, in the precondition of confidence interval, we have mentioned that this method is used for sigma is given. So this number sigma is given in the question, and the sample size that is given too in the question. We can get that number when we get a sample. And mu, this one, the population mean, is the underlying population mean of the X bar. So we know that this number is not given. It's unknown, right? Because the confidence interval is to estimate the range of mu. So mu is not given. So we will find that in this formula, all the numbers are given or are known except mu. So we need to transform this formula to mu. So we will find that mu equals to X bar minus Z times sigma over square root n, right? But we will find that this is only one number, not a range. We said that the confidence interval should be a range from number A to number B between these two numbers. That is range, right? But here, there is only one number. So, what's the meaning of that? How can we get the range? Please do not remember that. Please do not forget that. Here, Z. This number is what we can get from the appendix table A1. But the normal distribution, the normal distribution curve is symmetric. So that means the curve is symmetric about Z equals to 0. So if here is a Z value which is a negative number, there must be a positive number of Z, and they have the same area outside these two numbers. That means the left part and the right part, the area of these two parts, they are the same, right? These two numbers are symmetric about Z equals to 0. So here we actually have two numbers of Z. The first one is plus, is positive Z, and the second one is negative Z. So we put all these two numbers here. We will get two formulas. The first one is X bar minus Z, the absolute value Z, times sigma over square root n. And the second number is X bar plus absolute value Z times sigma over square root n. Okay, so now my question. Both of these two numbers, which one is smaller? Yes, this one is smaller, right? So this is the lower bound of the confidence interval. And this one is a bigger one. That is the bigger bound, the upper bound of the confidence interval. So when we are talking about the 1 minus alpha confidence interval, that means the range between these two numbers. If we use the method based on Z distribution. Okay, so let's go back to our PPT. Okay, so here, now you can know how can we get the formula. This is the X bar minus the absolute value z times sigma over square root n. And this is the x bar plus the absolute value of z times alpha over square root n. So what's the meaning of half alpha here? We said that in the table A1, we can find the z value and its corresponding probability, right? And that probability is alpha. So alpha means the probability in the table A1. So most oftenly, when we are trying to solve a question about confidence interval, the probability should be given. For example, I want you to figure out the 95% confidence interval. So that means alpha 95% equals to 1 minus alpha. So alpha equals to 0.05. So half alpha should be 0.025. And with this probability, we can find out its corresponding z alpha in table A1. So that is what's the meaning of z half alpha. Okay, so 1 minus alpha confidence interval is between these two numbers. It's the range between these two numbers. So please notice that the confidence interval is normally used when an interval estimate of mu is desired, in which the probability of interval actually covering mu is 1 minus alpha. So we have just mentioned that the probability for the confidence interval which is covered mu is not exactly equal to 100%. It should be 1 minus alpha percent. And most oftenly, this probability 1 minus alpha should be given in the question, and we can know the number of alpha, and then we can find out the corresponding z half alpha in the table A1. Okay, so now let's do an exercise. With the data of the example 5.1, please find a 95% confidence interval for mu using the sample results given in sample 5.1. And then let's think about what informations are given in that question. The first one is the little n, the sample size, right? And the x bar, the mean of the sample. And sigma is corresponding standard deviation, SD. And here, the question is about 95% confidence interval. So this is the probability, and that is exactly equal to 1 minus alpha. So that means alpha equals to 0.05. So we need to find out z half alpha. Z half 0.05. And I think Teacher Gao have taught you when alpha equals to 0.05, and we are talking about the two sides probability. So the z value should be 1.96. We can also find it in our textbook. Here, let's find this probability, because this is in this question, the probability is given. So we need to find the probability first. So here we find that half alpha is 0.025. So this is the probability of half alpha. And its corresponding z is minus 1.96 because this number is in the cross position of minus 1.9 and 0.06. So the corresponding z is minus 1.96. Okay, so here we find that this is the number of z value when half alpha equals to 0.025. Okay, so next one, let's put all the numbers into the formula. The formula, do you remember the formula? Yes, that is x bar minus z absolute value times sigma over square root n. And another number is plus. Yes, so here we have already know all the numbers which should be used in the formula, and we just put all the numbers into the formula. Here we put all the numbers into the formula, and we can find the range is between 175.56 and 187.48. So we can say that the population mean is between these two numbers. Mu is bigger than 175 and less than 187. Or we can just use this type or bracket 175, 187.48. The two numbers in a bracket. So that is also correct. So this is the range, or this is the 95% confidence interval for mu in this question. Okay. So now here is a question for you. That is an exercise. You can try to solve the question, and you can write the answer down in a paper. And a few minutes later, I will show you my answer.